Foundations are everything. They support our homes, keeping them level and stable. A strong foundation means a strong house. One common and reliable type is the continuous footing. It's a strip of concrete running continuously under load-bearing walls. This spreads the building's weight evenly across the soil. Continuous footings are crucial in areas with expansive soils. These soils shrink and swell with moisture changes. The continuous design helps minimize this risk. They also resist frost heave in colder climates. These footings are made by digging a trench along the load-bearing walls. The width and depth depend on the soil-bearing capacity. Steel bars are often added for extra strength. Then, concrete is poured, forming a solid base. For a healthy home, a dry foundation is crucial. That's where vented foundations come in. They are designed to prevent moisture buildup in the crawl space or basement. Moisture leads to mold, rot, and even structural damage. Vented foundations combat this with proper airflow. Vents are strategically placed openings in the foundation walls. These vents allow for continuous air circulation, removing stale, humid air and replacing it with fresh air. This process, known as passive ventilation, helps regulate moisture levels and prevents condensation. But ventilation alone isn't enough. A well-designed system also includes vapor barriers. These barriers are installed on the ground or crawl space walls. They prevent moisture from the soil from migrating into the crawl space. Together, vents and vapor barriers create a dry and healthy foundation environment. Designing a vented continuous footing foundation is a careful balance of structural integrity and ventilation efficiency. It starts with understanding the soil conditions. Soil tests determine the bearing capacity and drainage characteristics. Next, we calculate the building's load. This includes the weight of the structure itself, along with any anticipated live loads like furniture and occupants. Using this information, we determine the footing's dimensions, width, depth, and reinforcement requirements. Vent placement is critical. Building codes typically dictate the minimum vent area required based on the crawl space size. These vents should be evenly spaced around the foundation perimeter. Their location should maximize cross-ventilation, ensuring a constant flow of fresh air. Section 4. Installation Best Practices. A well-designed foundation is only as good as its installation. Attention to detail is paramount. The process begins with excavation. The trench must be dug to precise specifications. Compacting the soil is crucial. This creates a stable base, preventing future settling. Next, we install the formwork. These structures hold the concrete while it cures. Steel reinforcement is placed within the formwork. Then, concrete is poured and vibrated. Once cured, the formwork is removed and backfilling begins. Proper sloping directs water away from the structure. Section 5. Types and drainage solutions. Continuous footings come in different forms, each tailored to specific site conditions and structural requirements. T-shaped footings are common in areas with expansive soils. The wider base provides greater stability. Stepped footings are used when building on sloping sites. They follow the slope of the land, ensuring a level foundation. For lighter structures, a simple rectangular footing might suffice. Drainage is crucial for any foundation, especially vented ones. We need to keep water away from the foundation to prevent hydrostatic pressure and moisture intrusion. This often involves installing perimeter drains around the foundation. These drains collect water and direct it to a safe disposal point, like a sump pit or daylight outlet. Section 6. The future of foundations, ventilation and beyond. The future of foundation design is all about sustainability, energy efficiency, and resilience. Vented foundations, with their passive ventilation systems, already contribute to energy savings by reducing the need for mechanical dehumidification. But we can go further. Advanced materials like insulated concrete forms, or ICFs, offer superior insulation, further improving energy efficiency. These forms are lightweight, durable, and resistant to moisture, making them ideal for foundation construction. Building Information Modeling, or BIM, is revolutionizing the design process. BIM allows us to create virtual models of buildings, including the foundation. This enables us to optimize designs, identify potential issues early on, and improve collaboration among different trades. The future of foundations is smart, sustainable, and built to last.